Okay, good morning, all students. I hope I am audible to all of you. Am I audible?
Yes, sir.
Okay. So, welcome back after the Diwali vacations. Before Diwali, we have already finished 4 units of this particular subject, Digital Electronics and Computer Organization. Since the fourth unit, we have started with the second part of the subject, that is computer organization. So in the fourth unit, we have seen the architecture of MIPS processor, which is uh, a RISC kind of processor. The MIPS processor supports the pipelined architecture. So how instruction pipelining can be implemented in the MIPS processor, that we have seen in the last unit. Uh, Now, this fifth unit is about memory and I/O organization. As we have already discussed, the computer consists of CPU, memory, and input-output. Sometimes it is just called CPU and peripherals. So CPU, that is central processing unit, and peripherals, that is the memory and input-output devices. So memory and input-output devices, they are the important part of any computer system. So in this unit, we are going to see how is the memory and input-output devices are organized, or how they are connected to the CPU. So let us first begin with the characteristics of the memory system. First, we shall focus on the memory and later on the I/O organization. So you are aware that memory, your computer contains memory, and this particular memory comes in the various forms. The main purpose of the memory is storage. So what you need to store in the computer, of course, there are two main, you can say, things that you need to store in the computer. One is the program or your code. You need to store your program or code in the memory, and another one is that you need to store data into the memory. So memory is used for storing the data, or memory is used for storing your code or program. Of course, the data comes in the various form. It can be multimedia data and all that. There are various ways in which the memory can be implemented. One of the implementation we have seen in the digital electronics, that is the flip-flop. The latch is the basic, you can say, circuit which stores the bit, binary bit, and you can construct the flip-flops or group of flip-flop, that is registers or large number of flip-flops that constitutes the memory. So that is one type of implementation of the memory. The computer memory is essentially required to store the information in the form of zeros and one. Okay, so the main characteristics of all the computer memory is that it should be able to store the information in the form of zeros and one. So there are different types of memory depending on how the information is stored, where the information is stored, depending on the location, capacity, unit of transfer, how is it accessed, how is the performance, then the physical type and physical characteristics, and the how it is organized. Okay, so these are some of the key characteristics of the memory system. Okay, based on the location, the memory can be classified or it is characterized either as internal memory or it can be characterized as the external memory. For example, the internal memory is the processor register. Okay, so we have seen with the MIPS processor that there is a register file which contains 20 registers. So this 32 register, not 20 register, 32 registers are there, each of size 32. The processor registers are the fastest one. Then in addition to that, you can have the either the program memory and data memory as a separate, which is called the main memory, or it can be combined. Depends on how is the organization of your processor. If it is hardware organization, then like MIPS processor, then they are separate. Whereas if it is von Neumann architecture, then the program and data memory is same, and that is called the main memory. Whereas many times this particular main memory is slower, and the processor needs the instruction to be fetched very fast, or data to be fetched or to be read very fast. So that is why in between the main memory and the processor, you have a faster memory, and that is called the cache memory. So cache is the kind of memory which is faster than the main memory, whereas it is not as fast as the registers. So registers is the fastest memory, you can say. So if something is stored in the registers, then the processor reads it very quickly, whereas if it is stored in the main memory, it will take a little more time, whereas the cache memory is faster than the main memory. Again, in a particular processor, there can be different levels of cache memory. So one cache may be faster than the other cache. So like that, there can be different levels. That is level 1 cache, level 2 cache, level 3 cache, and like that. So this is all about the internal memory. So it is possible that a processor would read directly from the internal memory. Whatever data or code is stored in the internal memory, then it can be directly read by the processor. Whereas there is external memory. For example, the optical disc, magnetic tapes, or magnetic disc. So all these comes, or nowadays even your pen drives, flash memory, and all these things. So these are the examples of the external memory. Okay. So these external memory, they are not directly connected to the processor, but they are connected through input-output devices. But the characteristics of this particular external memory is that data is permanently stored into it, and whenever computer needs to work with the data that is stored into the external memory, then that particular data need to be brought into the internal memory. So your data or your programs may be stored in the external memory, but if that data, if computer needs to work with that data or those programs, then those programs or data need to be brought into the internal memory. Okay, so whenever we start some program, usually that particular program is stored in the pen drive, or that program is stored into the hard disk. And when we start that particular program, we say that that particular program is loading. So that program is loading means what is happening. It is being copied from the external memory into the internal memory. Okay, so that is the external and internal memory. Again, you have the different characteristics for the external and internal memory. Internal memory, it is volatile, that is after you switch off your machine, then whatever contents are there in the internal memory, usually those contents, they are vanish, so it is volatile. Only in the ROM part the contents will remain. Whereas the external memory is not volatile, so whatever you write on the external memory, whatever data programs are there on the external memory, that is on the pen drive hard disk, unless you delete it, it will remain there on the external memory. As far as size is concerned, the capacity is concerned, then uh, the external memory usually is huge as compared to the internal memory. Okay, so you are aware that the hard disk sizes, they come in the terabytes and all that, whereas the internal memory of the processor, they come in gigabytes. Okay. Then the next characteristics is the capacity. Okay, so how the memory is organized. Is it organized as the words, or how many? What is the size of that memory? How many number of words? Usually, it is measured in terms of the bytes. Okay, so usually the registers are few bytes. The cache memory is few kilobytes. Now it is few megabytes. Main memory nowadays, now it is in gigabytes, whereas the external memory, they comes now in the gigabytes or terabytes. So like that, you have the different capacity for the memory, and depending on the uses, you have the different uh, capacity for this particular memory. Okay, usually the internal memory, which comes in major two categories, that is the static memory and dynamic memory. So in that case, most of the part is implemented as the dynamic memory, because the size required for this particular memory is smaller, and the uh, cache is usually implemented using the static memory. Okay. Then the access method, the memory, how it is accessed. Earlier, for the tapes type of memory, that was that was sequential access. Nowadays, the direct access is very common in the flash memories and the internal memories. Okay, whereas there can be random access. Okay, in the for the internal memory, that is nowadays it is the random access, that is any memory can be accessed randomly, whereas in the sequential, so you need to go into the sequential form, usually it is tape, so the data is stored sequentially, whereas in the on the hard disk, even the data is stored in the cylindrical disk or circular. So that is there. It is somewhat mixed storage, you can say. So it is not purely random access, or it can be associative. Okay, so these can be the different methods. We shall see the different accesses later. The performance of the memory can be measured, and the different memory can be compared based on the access time, how much time is required for accessing. For example, the access times for the static memory uh, is very less than the access time for the dynamic memory, whereas the access time for the external memories, it is high. Okay. Then cycle time, that is the time required for completing uh, one cycle. So that is uh, starting from reading of that particular uh, data or writing to that particular data. So that is called the cycle time, whereas access time is just within how much time that memory is available. So that is the access time. The transfer rate comes when it comes to transfer huge amount of data to the memory. So that is the transfer rate. So how many kilobytes per second can be transferred is the transfer rate usually. So this is how the performance of the memory uh, can be computed, and you can compare the different types of memory based on these particular parameters. In the physical types, the memory comes in the semiconductor form. Okay, for example, usually the internal memory is in the conductor form. So the static RAM or dynamic RAM. So these are the examples of this semiconductor memory. It can be magnetic. For example, your hard disk or the magnetic tapes, they are the example of the magnetic memory. So the magnetic property is used uh, for storing the bits 0 and 1 on the magnetic uh, you can say surfaces. Okay, the surface which is polarized. Okay, uh, so you can polarize that particular magnetic material such that somewhere you will be storing the 0 and you will be storing 1. Okay, so uh, the magnetic cells are formed on that particular material. Okay, so if required, you can go into the details of how zeros and 1 are stored on the magnetic material. Okay, so is the case with the optical devices. So it is the compact disc or DVDs or CDs. So those are the optical devices, and data can be stored or programs can be stored on those optical discs even. Okay, so it is stored usually on the surfaces, so making the surface reflective or non-reflective makes that particular disk to store 0 and 1, and later on using the LED or laser beams, the data is read or written from that particular those particular optical disc. Uh, then magneto-optical, the combination of this also can be used for storing the data. So depending on the physical type, you can have the you can characterize the memory. Then physical characteristics constitute volatile and non-volatile. So internal memory, they are volatile usually. Nowadays, internal memory, flash memory is coming, and that is non-volatile type of memory. That is when power goes off, whether the contents are retained or not retained. So that determines whether the memory is volatile or non-volatile. Okay, usually the static and dynamic RAM, they are the volatile memory, whereas the other type of memory, external memory and ROM, they are non-volatile memory. Then erasable and non-erasable, usually it is for the optical disk, whether you can erase it or you cannot erase it, or it is applicable to ROM also. So if it is erasable, if you can modify the contents of that particular memory, it is called erasable. Whereas if you cannot modify it, then it is non-erasable. Okay, so earlier the CDs used to come, and those CDs you could only once write, and after that it is not possible to write into it. Okay, so those are non-erasable. Okay, whereas the erasable ones, they can be written any number of times. Okay, so that is applicable to ROM also. Even the ROM, they are coming in the form of, that is EEPROM. EEPROM means erasable programmable ROM, that is read-only memory, and they can also be erased. Then how memory are organized, that is memory modules, whether it supports the modules, and from the smaller memories, is it possible to build the bigger memories? So does it support that? So depending on that, how or how memory is organized for one type of memory to the other type of memory. So that is also one of the major characteristics of the memory. Okay, so we shall go into the details of all these characteristics. The method of accessing the memory, as it was shortly discussed, that was the random access or the sequential access. So those are the two major types of the memory. Sequential access consists of memory is organized into units of data called the records. Okay, the access must be made in a specific linear sequence. Okay, so you have the records stored in the memory, usually on the tape. So stored addressing information is used to separate records and assist in retrieval process. So a shared read-write mechanism is used, and this must be moved from its current location to the desired location, passing and rejecting each intermediate record. Okay, so thus the time to access an arbitrary record is highly variable. So tape units are sequential access. Okay, so this is how is the sequential access memory. So there is current location, and with respect to the current location, you read the records either on the previous record or the next record. Okay, so to go to the target record, the required record, you need to access all the records which are in between the current record and that particular target record. The direct access, as with the sequential access, the direct access involves a shared read-write mechanism. However, the individual blocks or record have a unique address based on physical location. So access is accomplished by direct access to reach a general vicinity plus sequential searching, counting, or waiting to reach the final location. So again, access time is variable in this case. So disk units, they are the direct access memory. Okay, so the access that is being used on the optical disk, or the access that is used on the hard disk, is called the direct access. Okay, then the random access, so it is Each addressable location in the memory has a unique physically wired addressing mechanism. The time to access a given location is independent of the sequence of prior accesses and is constant. Thus, any location can be selected at random and directly address and access. So the main memory and some cache systems are random access memory. Okay, so randomly you can access any memory and the time required is constant in case of the random access memory. Okay, whereas the associative, this is a random access type of memory that enables one to make a comparison of desired bit location within a word for a specified match and to do this for all words simultaneously. Thus, a word is retrieved based on a portion of its contents rather than its address. Okay, so the method of accessing memory is different. So it does not have the address like the other type of memory. Okay, typically the internal memory. That is why this is also called the content addressable memory, that is CAM. So as with the ordinary random memory, each location has its own addressing mechanism and retrieval time is constant independent of the location or prior access patterns. The cache memories may employ associative access. So usually in the cache memories, to implement the cache, this associative access is used. Okay. Then coming to the performance parameters of the memory, one of the important parameter is the access time, that is the latency. So for random access memory, this is the time it takes to perform a read or write operation. That is the time from the instance that an address is presented to the memory to the instant that data have been stored or made available for use. So that is the time. This particular time is called the access time. Okay. For random access memory, access time is the time it takes to position the read write mechanism at the desired location. Okay, so the uh, non-random access types of memory, they are the tapes and all that. Okay, so for that the access time is the time to required uh, to take that particular pointer, memory pointer, to the desired location. Okay, usually in case of the head tapes, there is a read write head, and that particular read write head need to be properly located at the position where the data is stored. So that mechanism is there which rotates that particular tape or disk to the desired position. Then another parameter is the memory cycle time. So this concept is primarily applied to the random access memory and consists of the access time plus any additional time required before a second access can commence. So uh, that is the memory cycle time. So this additional time may be required for transient to die out on the signal lines or to regenerate data if they are uh, read destructively. Okay, so this is the memory cycle time, that is the complete time between the two different read or write or read followed by write operations. Note that the memory cycle time is concerned with the system bus and it is not with the processor. This particular buses, they connect the processor to the memory. Okay, so the characteristics of the buses also play an important role in the memory cycle time. The transport rate, so this is the rate at which the data can be transferred into or out of the memory unit. For random access memory, it is equal to 1 divided by the cycle time. Whereas for the non-random access memory, the following relationship holds, that is Tn is equal to Ta plus n divided by r, where Tn is the average time to read or write the n bits, whereas Ta is the average access time, and where the n is the number of bits to be read or written, whereas r is the transfer rate in bits per second. So this is how you can calculate the transfer rate. Okay. This is the pyramid which shows the memory hierarchy. At the uh, top of the pyramid is the fastest memory. So the registers are the fastest memory, followed by the cache and the main memory. So these are classified as the internal memory, okay, the registers, cache, and the main memory, which are closest to the processor. So they are the inboard memory, okay, or onboard memory. Then the magnetic disk, CD-ROM, CD read-write, DVD read-write, DVD RAM, or Blu-ray. So all these memory, so they are the outboard storage memory, and the offline storage memory, they are the magnetic tapes that you can disconnect, and uh, again when required you can recorrect. Okay. So when you go from top to bottom, then the speed is going to decrease. Okay, so these are the slowest one. Magnetic tapes are slowest one, but whereas the resistors, they are the fastest one. Okay, if we see the cost of implementation of this particular memory, the per bit cost. Okay, what is the cost to store one bit? So the cost required for one bit storage in case of resistor is high, whereas the cost required for storing one bit is very less. So that is in case of the magnetic tapes, okay, or the Blu-ray disc. Okay, so the cost is going to decrease as you go towards the bottom of this particular pyramid. Okay. Again, the capacity, how much capacity you can have. So in the processors, you cannot have the memory with very huge capacity. Okay, so usually because of the characteristics of the resistors, the cost of the resistors, and other parameters associated with the resistors like power consumption and power dissipation, you need to have less number of resistors. So the capacity of the resistors is very less. Then the capacity of the cache memory is higher. Capacity of memory, main memory is still higher, whereas the capacity of the outboard storage is huge as compared to the upper types of memory. Okay, so the capacity goes on increasing as you go towards the bottom of this particular pyramid. The power consumption goes on decreasing. Power consumption goes on decreasing as you go towards the uh, bottom of this particular memory. Okay, so you can see here written in the text form, as one goes down the hierarchy, the following occurs. Decreasing cost per bit, cost is going to decrease as you go towards the bottom of that pyramid. Increasing capacity, capacity increases. Resistors, they have the less capacity, whereas the disks, they have the highest capacity. Increasing access time, access time required is increasing, so resistors are fastest, very less time, whereas the disk, they are the slowest, more access time. And decreasing frequency of access of the memory by the processor, that is the speed at which the memory can be accessed, so that also uh, it is decreasing. Okay, so that is how is the characteristics. So having discussed the characteristics of the memory, now let us go towards the memory, uh, the part of the memory that we shall be studying in little detail, and that is the cache memory. Okay, and how is this particular cache memory organized? Okay, so in this particular unit, we are going to see organization of the internal memory, and that is the cache memory, and the main memory, that is how the virtual memory is implemented. So in the beginning we shall see what is the cache and how cache memory is implemented. Okay, so today we shall have a little discussion on what is cache, and in the next class we shall go for actual organization of the cache. Okay, so you can see on this particular slide uh, that between the main memory and the CPU, there is a memory, and that particular memory is the cache memory. Okay, so it is present between the main memory and the CPU. Okay, so CPU usually reads from the cache. Okay, so whatever data or the code or the instruction are required by the CPU, so they are read from the cache. The read and write from the cache is very fast. Okay, so that is why CPU usually reads or write into the cache. Okay, so this particular transfer is word transfer. That is, it reads one instruction at a time, or it reads one word of data from the cache at a time. Okay, but whole of your instructions or whole of your data cannot be stored into the cache memory, though that particular cache memory is faster, but the size of the cache memory is less. The size of the cache memory is less, so only few blocks can be stored into the cache memory. Okay, so what happens when CPU needs some instruction from a block which is not present in the cache, or when CPU needs some data which is in the block that is not present in the cache? So in that case, what happens? Uh, in that case, the block is always present in the main memory. Okay, so all the blocks are present in the main memory. So from the main memory, the required blocks, they are brought into the cache memory. Okay, so the execution of the program halts there itself. Okay, and the block which is required is transferred from main memory to the cache memory, and then the CPU operation proceeds. Okay, so that CPU finds that particular data, or CPU finds that particular instruction in the cache memory. Okay, and the further operations, the subsequent instructions and subsequent data is expected to be in the same block, and the CPU continues working with the newly fetched blocks. Okay, whereas because this is limited, the cache is limited, so many times it may be required that some block need to be overwritten. Okay, or some block need to be swapped into the main memory. The blocks which are not required by the CPU, so they are swapped back into the main memory. So this is how is the cache. Okay, so if the cache would not have been there, then CPU need to directly read from the main memory, and in that case, the time required for fetching the instruction or the time required for reading the data from the memory would have been more. Okay, so that is why CPU uses the cache. Okay, so by using the cache memory, the overall time required for execution of your program is less. Okay, so the main purpose of using the cache memory is to increase the speed of execution of the program. Okay, so we have already seen in the last unit that the how many instructions are executed per second is one of the uh, uh, important characteristics of a particular computer. Okay, and execution of the instruction does not depend only on how is the architecture of the processor, but it also depends on how the memory is organized, how is the how fast is the memory. Okay, so having the cache memory by having the cache memory in between the main memory and CPU, we can improve or we can increase the performance of the execution of the program. Okay, so you can increase uh, the MIPS rate of a particular processor by using the cache in this way. Okay, now the upper diagram shows that only one level of cache is used, but if you see the B diagram, so in that case between the CPU and main memory, uh, three levels of cache is used. Okay, so level one is the fastest cache, whereas level 2 is the fast cache, whereas level 3 is the least fast cache, whereas the main memory is the slowest one. Okay, so the difference in these is that the size of each of the cache is higher. Level 3 cache is higher than level 2. Level 2 is higher than level 1. Okay, whereas the block size also varies from level 1 to level 2 to level 3. So if the blocks are usually CPU always read from the fastest one, whereas if the block is not available, then it will be searched into the level 2. If it is available there, it will be taken into level 1. If it is not there, then block will be searched in the level 3 first. If it is available there, then it will be transferred to level 2. Even if it is not there, then the block will be searched, or in the main memory it is always there, and from main memory it will be taken into level 3 and then level 2 and level 1, so that it will be available to the CPU. Okay, so this is how is the three level cache organization in many of the processors. Okay, so this is how the cache is organized. More details about the cache memory we shall see in the next class. Okay, so if you have any queries on this characteristics of the memory or the cache memory, then you can raise your queries. Yes, understood. Any problem in this?
Yes, sir, understood. No problem.
Okay, so comparatively, this particular unit is bit uh, easier than the last unit. The fourth unit is typically very, you can say, uh,
Quite difficult.
tricky to understand, especially the pipelining concept, the different types of hazards, and all these things. So I would like that you keep on revising the fourth unit. Uh, if any problems are there, still if required, we can revisit certain points from the fourth unit. Okay, but before that, you must have a reading of the concerned topics. Okay, uh, so if you do not have any problem, then we can proceed to the next class. I hope all of you have marked your attendance. If someone is left, can stay back. I will immediately mark the attendance. Okay, you may leave the session now. Okay, good day.